Hi, it's Mrs. Golding. We're going to work on Friday paper 17 today, and I'm going to start here with number 4. Quotient, of course, means we're going to divide. I'm going to go ahead and use the box method as I divide. So I'm going to go ahead and make my box for my dividend. Dividend goes in, sounds the same, right? Dividend in the box. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's the number of digits. 62.084. Okay. And then my divisor is here. Okay. We're going to multiply by a factor of 10 in our dividend and our divisor because it's going to be a lot easier to use a whole number divisor. 34 does not go into 6, right? When I subtract, then I bring up the 62, right? But it does go into 62. It doesn't go in twice because that would be, 68? So it goes in once, and that's 34. And when I subtract, what is that, an 8 and a 2? And then I can bring up both of those digits right here, okay? So I've got 280, and I'm going to try to guesstimate how many times 34 goes into 280. I'm thinking about 7. When I think of 28, just the number 28, I think 7 goes in there 4 times. So if 7 times 4 is 28, I could try 34 times 7. I think that's going to be a little too small. See what I'm saying? 248. So I'm thinking I could go up 1 more. So 8 times 4 is 32. 8 times 3 is 24, 27. Yeah. And in that case, there's only 8 left when I subtract. These are all subtraction. Bring up that 8. And then 34 goes into 88 only twice. And 34 and 34 is 68, right? And when I subtract, I get 20. And then I get 204. Now, we know 7 is too big because 34 times 7 was 248. So let's try 6. 6 times 4 is 24. 6 times 3 is 18 plus 2 is 20. Okay? So it works out nice. So my quotient is just 18 and 26 hundredths. I don't really need this 0 here, do I? So 18 and 26 hundredths. So let's go to the next one. And I'm going to do number 5. I probably did 6 in class with you. So it says write an equation in slope-intercept form for the line that passes through the point and has the given slope. So slope-intercept form, y equals mx plus b. And I'm going to plug in what I know. So this is an x value, this is a y value, and this is my slope. So let's plug in the y value here, 2, and my m is negative 1/3, and my x is negative 3, but I don't know my y-intercept. So we're going to solve for b. So let's just solve here. 2 equals, what's 1/3 of 3? Is that 1? In this case, it's 1/3 of negative, nope, it's negative 1/3 of negative 3. So a negative times a negative is a positive, and it's going to be a positive 1 plus b. So then we're going to subtract 1 from both sides, and we see that 1 is equal to b. So some of you, when you're doing these, you think that 1 is the answer, or b equals 1. But that's not what the question is asking. It says write an equation. We need to write an equation. So we're going to use slope-intercept form. And so my answer is going to be y equals mx plus b. Negative 1/3 x. And it's a positive 1, so it is plus 1. And that's my slope-intercept form with a point and the slope. Okay. Algebra 1, you're learning how to do that a different way. using something called point slope form. So that will become important. Let's look here. Okay, simplify. The square root of 7 squared. Well, I don't know what the square root of 7 is, but I'm going to try something because I know what the square root of 9 is. I'm just going to test it and see what happens. What is the square root of 9? I have to do parentheses first. Like if you think of order of operations here, I don't say, I have to do what's in the parentheses first. So order of operations, square root of 9 is 3, right? So 3 squared is 9. Okay, so it came back here. Let's test it again and see if that happens. I know what the square root of 16 is. And I want to know what the square root of 16 squared is. Well, the square root of 16 is 4. And that, when you say square root, remember that's what number times itself equals that number. So 4 times 4 is 16. So 4 squared equals 16. So it seems to be when I take the square root of a number and square it, it comes back to the number that's under the radical sign. So if that's true, what would the square root of 7 squared be? It would just be 7. Okay? This is a pattern that we use in mathematics. If you don't understand the problem that you're given, write one that's similar that you can solve and then figure out the pattern behind it. That's what a good mathematician does. That's one of our tools. So let's go here. Write 2.956 times 10 to the negative 2 as a decimal, in decimal notation. In class, we also called that standard form. So standard notation. So let's go ahead and think about this. Is that going to be a small number? It is. That negative exponent tells me it's going to be small. So I'm going to go ahead and think about, I need to move this way too. So number 9 is going to give me, it's been a minute since we've done these in class, so I wanted to be sure you had a reminder of them. 0.02956. Oh, that's an X. Let's not put an X here. That's supposed to be a 6. 6. Make sure I'm right. 1, 2, yeah. So we move the decimal 2 places to the left. That's the decimal form. And number 10, we're going to put this in scientific notation. So I've got to find a number here where I have to make a number between 1 and 10. Remember, the number has to be greater than 1 but less than 10. So I'm going to put, that's a fire drill, ladies and gentlemen. I'll be right back. Okay, back from the fire drill. That was exciting. Guess we have to have some kind of excitement around here, right? Number 10, I believe I was trying to make a number between 1 and 10 out of 42,800. So I'm going to come here, 1, 2, 3, 4. If I move that decimal point from the end, remember if it's on the right, it's out of sight. If I move it back, I'll get the number 4.28, 4 and 28 hundredths. And that is between 1 and 10, okay? But I need to multiply that because I want to make the equivalent of that times 10, and I moved 1, 2, 3, 4 places. So it's going to be 4 and 28 hundredths times 10 to the 4th power, okay? Let's see. All right, so for this, in this grouping, I'm going to do number 12, and this grouping is on your Friday paper because there are problems like this that have shown up on iLearn and other testing that you've had or that you will have. And so I wanted you to be familiar with this. In a testing situation, there'll be boxes that you click to make a check mark in to show if it has no solution, infinitely many solutions, or one solution. So number 12, we have 2w, I'm just going to rewrite it, 2w plus 4 equals 2 times the quantity w minus 2. And so anytime I see those parentheses on the right, that tells me I need to distribute. So 2w, and this is 2 times 2 is 4, but it's a negative 2, so that's a minus 4, right? So you might already notice it's very similar on both sides. If that had been plus 4, then it would be infinitely many solutions because it's the same expression on both sides. They're different, so I can continue, and eventually you're going to be able to see earlier what's going to happen, but these variables both fall out, don't they? So I get 4 is equal to negative 4. Is that a true statement? No, 4 does not equal. So 4 is not equal to negative 4. And therefore, that means there is no solution. So if you get a false statement at the end like that, then there's no solution. That means there's nothing you can put in for the variable w. There's no solution that you can put in for w that will make that statement true. In other words, you can't get both of those expressions to be true. It's not possible. So let's go to the next one. I was going to do number 14 on this side. And this one says solve each of the following equations and place an X in the box with the correct solution. So this is going to be the same kind of issue where on iLearn or some of your other testing, you'll have these boxes to check with the answer. So I just wanted you to be familiar with that kind of a look. Let's see, I think I can combine like terms here, right? So let's look and see what we've got. We have this term and this term, right? And then I have my constants, negative 4 and 8. Okay, so let's go ahead and I might go ahead and, there's so many ways I could do this. I'm just going to move from left to right. I'm going to find the additive inverse of negative 3c, and that's positive 3c. So I'm going to add 3c or put a positive 3c here. So I'm left with negative 4 equals negative 2 plus 3. Is that a 1? And that's 1c, right? So I'm just going to literally write 1c plus 8, right? And so then I can subtract 8, and then I get c is equal to negative 12. And maybe you approach this problem differently. Maybe you added 4 to both sides. In any way you do it, you're going to get the same answer. So I'm going to put an X. I'm going to follow my directions. It says place an X in the box with the correct solution. If this were an iLearn type question, you would have a checkbox that you would check. Okay. Number 16 will be our final. In this case, a lot of times when you see that c over 2, that confuses everybody. It's just some number divided by 2 minus 3. Okay, it's just that. Don't think of it just like a fraction and you're all messed up and saying, I don't know fractions, I hate fractions, I'm just going to give up. Don't do that. Just think it through. And here I'm going to start by adding 3 to both sides, because I'm going to get closer and closer to that variable c that I want to isolate. So negative 9 plus 3, negative 6 is equal to some number c divided by 2. So something divided by 2 is equal to negative 6. So I'm going to undo division with multiplication. I'm going to multiply both sides by 2. And so this becomes, if I think about it like that, 1, 1. 1 times c is just c. So c equals 2 times negative 6 is a 12. What did I do wrong? I missed something. 2 times negative 6 is a negative 12, right? All right. So be careful, especially on when you're given answers, because you can immediately say, oh, yeah, 12. And instead it's, I got to check my signs. It's a negative 12. So both of those have the solution negative 12. All right. What could I tell you today? I'm going to just, my statement for today, make someone, I shouldn't say make someone, but make someone smile. I know they have to choose to smile, but do something that will cause somebody else to smile. It brings you